A statistician's wife had twins. He was delighted. He rang the minister, who was also delighted. "Bring them to church on Sunday and we'll baptize them," said the minister. "No," replied the statistician. "Baptize one. We'll keep the other as a control." So, good thing you're not children of statisticians. Anyways, we are going to be talking about control groups and experimental design. But one of the key parts of experimental design is random assignment. If this is messed up, the rest of the experiment's messed up. All subjects must have an equal opportunity to be assigned to any of the treatment groups. And so how do you show random assignment? Well, we're going to take an example where we have 14 middle schools. Remember, we had talked about this before. In the random assignment, we show it right here. These are our subjects. We're going to do random assignment and split them into two groups. Now, on free response, when you take the AP test, the diagram is not good enough. You have to explain how the treatments are assigned and what will be measured and compared. So just for assignment, first of all, how do you assign the 14 schools? You can basically say the hat method. I'm going to put, there are only 14, so the hat method or a simple random sample, the old-fashioned way, works really well. You could use technology. You could say, okay, I'm going to number the schools 1 through 14, and I'm going to use a calculator to generate 7 random numbers from 1 through 14, and those 7 I select will be in group 1. Or you could use a random number table, same way, except when you use a random number table, remember you need to tell me what to skip or ignore. So the hat method is always the simplest. Writing each subject on the name of slips, put all hats, mix thoroughly. If you don't tell them to mix it, you might get dinged. In fact, you probably will get dinged. Draw them all out one at a time until you have 7 slips. Everyone had a shot in being in the first group. This is good. And so 7 slips will get the career start. So this is how you could write your description on the AP test. Now, this is an alternate. You could write career start on 7 slips and regular curriculum on 7 slips, and that technically would work. Then you put the slips in a hat and mix thoroughly. For some reason, I just prefer the top one. I don't know why. Have the subjects come up one by one and pick a slip from the hat. I guess it's because it feels like they all get a chance to draw a slip, and that's why it's not my favorite. So it still guarantees 7 schools per group with treatments assigned by chance, and they all have an equal shot. So it's still fair. It just doesn't feel as good to me. All right. Using technology, again, what I was telling you before, give numbers 1 to 14 to the schools in random order. Use the calculator to produce numbers. Ignore any repeats. I didn't mention that. So I would have gotten dinged about the repeats. The first 7 different numbers chosen select the schools to participate in the first treatment. And then the remaining schools will participate in the random treatment. Using a random number table, we're going to have to basically ignore some. So here's the lines from a random number table. So you're going to read 2-digit groups moving from left to right. The 14 distinct labels between 1 and 14, and I really should say 0, 1, and 14, will be assigned to treatment 1, and the rest will get treatment 2. You need to ignore repeated labels and groups of digits from 15 to 99, and actually you also need to ignore 0, 0, which I left off here. Bad teacher. All right, so basically I went ahead and did this through. I had 84, 98, so I crossed out everything that was in the 15 to 99 group. If I'd had a 0, 0 here, I would cross that out as well. I really should list it down here. And you can see the first schools I pick are 12, 1, 2, 3, 4. Isn't that funny? 8 and 13. So those are my 7 schools that will be picked for the treatment. Now, what if I just flip a coin? So you could say, since there are only 2 treatments, it might be logical to just go through, flip a coin, and if it's heads, give them the first group treatment and tails the second. As long as all subjects toss a coin and get the result of their coin, this is still a completely randomized design. If we don't care how many are in each group, that is okay, but usually we like to have kind of balanced groups, so we do care. So if you force a group to be equal, you keep flipping until one of the treatments is filled, and then you put the other ones in the other ones. So you keep flipping until you fill either treatment 1 or treatment 2. The problem is the last subjects on the list will always be assigned to the unfilled group, and this can actually lead to bias because there might be a difference between the people at the end than the people at the beginning. So don't force the groups to be equal. Use one of the other methods. Now, you're probably still saying, I really don't understand why flipping a coin doesn't work. So let's revisit a warm-up problem we did. We split subjects Amy, Bettina, Carl, and David into 2 groups. And the groups are going to both be size 2. Heads is group A, tails is group B. Stop when you fill a group. So to get Amy and Bettina in one group, that would be heads, heads. The probability is 1/4 because 1/2 times 1/2 is 1/4. Tails, tails, the probability is 1/4. Heads, tails, heads, that probability is 1/8. Heads, tails, tails, that probability is 1/8. And you can see tails, heads, tails, and tails, heads, heads. So the problem is these probabilities are not the same. And the probability that Amy and Bettina are in group A by flipping a coin is 1/4. All right. The thing is, when I'm just picking from slips, I could pick Amy and Bettina, Amy and Carl, Amy and David. That's 3. Bettina and Carl, Bettina and David. That's 2 more, so I'm up to 5. And then finally, Carl and David could be a group. There are 6 possible different outcomes for this, but there are actually 16 different ways to flip these coins. And when I'm doing that, you see this red one is what I'm representing with the group, but I'm ignoring all of these outcomes. I'm ignoring heads, heads, heads. So when I do this with flipping the coin, my probabilities aren't matching well because there are heads, heads could mean any one of these 4. There are 6 different groups, so the probability should really be 1/6 for each. So that's why flipping a coin doesn't work when you're trying to split groups. The probabilities are not going to be the same for every group.